Alright, Mason robots, beep beep. We're dealing with fusion and fission. We'll do it from outside. I know it looks like a big scary place. Same stuff. Same stuff. You know, essentially we're just saying N1/2, first move, second move. I know that in chemistry, pawn E1 can be, you know, a prefix. It can be a anagram for space of exact energy design. That's a pawn. It can say space of exact energy design is P1, right? P2 is a seed, space, technology, engineering, and mathematics. Well, that's a space, science. Exact energy is a technology, engineering, design, exact energy design, mathematics. So you'll get into these translations, and here P1 to P2, you know, what is hydrogen, hydrogen 1 to helium in the quantum object that is physics, all this stuff. Get some of this, a little bit of that, some of this over here. These are our elements, obviously. Very practical on the floor from here. Now clearly these are Delaware Basin stones, but you've probably seen that before, yeah? You know, up, down, forward, back, forward, reverse, left, right. And, you know, given that gives me an X, Y, and Z. Now clearly I could say up and down and right in certain processes. That's the limit. You know, this is the only way to get hydrogen to helium in this form. First order, second order, and what will be comparable to the third order once this game is started. Again, we can find that there's a relationship of if I decided to move a pawn before this knight and still have this chessboard present itself. So you have to look in the middle and say, all right, so I know the Large Hadron Collider's ramping up some particles, shooting them at the wall. They do that so it's a faster science than any chemistry to get hydrogen and helium given the quantum limit or the standard model to say, really, I mean, you could put heat to it and oxidize, what is it? Oxidize, oh shit, what is it called? Fuck. Anyways, you put it in a little test tube, you heat it up, it'll turn orange, oxidize bismuth. And if you keep heating it, and like other elements that work inside of that operator, the temperature index is what the drunkard walk problem is between the heat, light, and sound in fusion, or fission. Essentially, we're just saying, well, what fusion is in an atomic bomb, here's the design, is essentially what fission does in a different quantum time space. I want all of that energy, instead of playing out in a trickle charge, to be battery packed and be able to move around in that form. So you'll see this terminal control via what they have there. And I've never worked those ones. That's Veer's territory. He's pretty much got that down. I don't have to worry about nothing. That says A1, first order to second order. This stone mill, M1, to this stone mill, M2, or Fermilab, the Large Hadron Collider, new nuclear technologies, Princeton, Stanford, MIT, Paris Island. You know, that in that form, if you understand what the physics represents, I'm going to start with that initial momentum. I'm going to start with hydrogen. I'm going to start with helium. I need something that does the magnetic turny things for that form because the energy releases of that composition. You know, math teachers teach math in class instead of philosophy, of monkeys smashing their faces off the computer screen here for a result. And that would be more efficient. That would be better than burning coal. Or an option that says G, gravity, equals the square root. I could say coal, I could say, we could say that's what I have abundant from that topology, or that one, or that one. Any of those forms. You know, that's what I need it to be in that representation. Most time in my life, given my costs and my brackets, all this stuff, you'd have to look at this and say, well, what do I really need here? What's what's really center mass to the directions and costs that I need. Because if I tried fusion or fission, well, there might be a little friction in here, and then I'm just saying, you know, not that it's a problem, or you'd have to understand that. You'd have to start making moves on that. Have the end game won, so people that challenge you on the information and technology that might be circuited down to a very specific line of a thermaler's position or something like that, actually know that, hey, you know, Rich is going to step down in here and he's going to say, really, these things diverge at times. They have very critical timelines to the feeds and speeds of the machine you got. And, you know, serviceability ratings, gas laws, just vacuum problems and stuff like that. So you really got to pay attention to that stuff. And again, you know, so nuclear technologies today like that, you know, I'm all for it. I really am. But I have problems with their physical limit and the end result cost via where things really I see need to be done today. You know, especially in the, not for the stonemasons or any companies. These are good gravity. I mean, I wouldn't knock their reference for what it is. It's really good. I mean, that's a great mill. And, you know, you have to look at that and really make, all right, well, then that's what I need to understand what those numbers are, because once I do realize, hey, you know, all these saw programs, they correlate to weird numbers that really don't make sense. They're irrational by any other standards, but essentially this is gravity, a very weak force, and anywhere else those numbers really wouldn't represent. But here in the quantum object, they would make perfect physical sense given timelines, X and Y. You know, here we got this incident right here, X to Y is still stone mill, but we're going to diverge that on some XY axes and say M1, M2, these are new measurement devices, and we can kind of compare to each other given tones and frequencies. You know, some little guy over there, you know, about that far away on the MiG-1, MiG-2 drawing, a whole pack of them over here. X's and O's in the hourglass, about why which one of these moves from that topology is something that makes the proper bluestone to carbon back into money and bluestone for you, because that is essentially fission, minus any diversified inconsistency, heat, light, and sound. Somebody's tweeting about something a little bit, you know, that would really say, well, we still lose it at fusion in the sun. It will burn out short of the dark core. I mean, if you can figure out a way to make the machine do a gravitational well without pumping energy into it, then that's just the composition of the materials, or maybe the composition of the materials of how they're positioned next to each other. And because of that, there's a very small weak force that, like a weight falling on a chain, turns on a light bulb for a very specific time. Then you have to reset it. What automatically in this universe picks up that weight? I mean, somebody has to come over to it, or the machine has to, by these linear straight lines that form spin, have to be compensated. That turbulent flow, or this y-axis, is a length of, well, right there, Jordan has to walk over. It's that wiggly squiggly line, and that's what keeps the heartbeat going here. And catch you on the next one.